Yes, good evening, everyone.
Good evening, sir.
Am I audible, guys?
Yes, sir.
Yeah, okay. So we'll start with a new topic that is your RAC, okay? Refrigeration air compressor. In this, we will be completing your refrigeration compressors, also your AC system, okay? Both the systems will be doing it together. All right. So on what principle my refrigeration air compressor works? Okay. What is the principle of operation? Anyone? Give me any one principle regarding this.
Vapor compression.
Vapor compression cycle. Very good. Okay. Anything else? So the first principle that it works on, it is
Thermodynamics second law.
yes, second law of thermodynamics. On part B. Okay. This is important. Part B you have to mention. Okay. Recently somebody has asked this question, principle of operation. So there are multiple that you have to give it to them. Okay. So what does part A says?
Heat flow from higher to lower.
Yes, heat flow from higher temperature region to a lower temperature region, right? But if we want the heat to transfer from a lower to higher, then we have to do some work. Okay. We have to do some work on the system to achieve it. Okay. This is by itself, the heat will always flow from a higher temperature to a lower temperature region, isn't it? Do you agree? Suppose
Yes,
I
sir.
have a metal, okay, which is at 100 degrees Celsius, and I keep one more metal on top of it. Okay, same material, one more metal I'll keep top of it. What will happen to this temperature? Suppose this is at 30 degrees Celsius. Okay, what will happen? This temperature will starts to flow to other, metal. Metal A temperature will starts to flow to the metal B temperature. Agreed? Without doing anything.
Yes, sir.
Yes. Yeah. But part B, what part B says is heat can be flown from lower temperature to higher temperature, provided that some work is done. And this work is carried out by the compressor. Okay, whatever the compressor will be there in the system, that will be carrying out this work. Is it understood, the first principle? First principle is it works on second law of thermodynamics part B. Okay, the second law of thermodynamics part A says that the heat will flow from a higher temperature region to a lower temperature region naturally, right? But part B says if we want to transfer the heat from the lower temperature to the higher temperature, then we have to do some work on it, okay, on the system. And that in this case, in your refrigeration uh, compressor case, the work that is done, it is done on the compressor side. Okay. Now the second principle is when gas is compressed above its critical temp pressure and cooled below its critical temperature, then we can convert it into liquid. This is your second principle. When a gas is compressed above its critical pressure and cooled below its critical temperature, then only we will be able to convert it into liquid state. So your refrigeration in the system, your gas, refrigeration gas is all gas also in the system, and at the same time in some places it is liquid, in liquid state, like your condenser. Do you agree? After the compressor, the gas is in your refrigeration gas, which is flowing in the system. Okay, that is in vapor state, but in the condenser, until it reaches to your thermostatic expansion valve in the system, it remains in liquid state. Do you agree? How the system is? You have
Yes, sir.
a compressor. Okay, after compressor, where it is going? It is going to
Condenser.
condenser, or I can write cooler. Okay, after cooler, it is going to
Expansion valve.
expansion valve. Expansion valve is known as thermostatic
ऑयल और
Thermostatic
ऑयल
expansion.
सेपरेटर में जाएगा ना सर?
PV. हाँ, what?
कूलर के बाद ऑयल सेपरेटर में जाएगा ना?
वो सब अभी छोड़ो, जस्ट जनरल बता रहा हूँ मैं साइकिल, ठीक है? एंड देन इट विल गो टू इवेपोरेटर.
Evaporator.
Evaporator is the one from where you are, suppose if I take a case of your meat room. Okay, so meat room is the room in which your coils will be there, evaporator coils, and that will take the heat from your meat room. Agreed?
Yes, sir.
And then it
Yes,
will
sir.
again go back to your compressor. Okay, so this is very basic figure, like how the system is flowing from the compressor. It will go to the cooler, from the cooler, it will go to the thermostatic expansion valve, and then from the expansion valve it will go to the evaporator, from where your heat will be taken out. Okay, from the room, whichever room you're cooling it, the heat will be taken out from that's why the temperature will drop down. Agreed?
Yes, sir.
Yeah, and then it will go to the compressor. So what I'm saying you here is, when the gas is compressed above its critical pressure and cooled below its critical temperature, then only we will be able to liquefy it. Okay, then only we will be able to make it liquid. यहाँ पे you agree, your refrigerant which is flowing in the system, it is in liquid state
Yes, sir.
until this, it is in 100% liquid state. Okay, इससे पहले your oil separator is coming, your filter dryer is coming. That is separate part. We will do it later on. But in general terms, till here it will be liquid state 100%. Isn't it? After
सर ये
that,
क्रिटिकल टेम्परेचर के बाद क्या लिखा हुआ?
critical temperature
ये एंड के बाद क्या लिखा हुआ है सर? एंड
cooled below its critical temperature. So till here it will be 100% liquid state. After here it will change slightly to 10% vapors and 90% liquid. But after evaporator it will be 100% vapor.
Yes.
Okay. After this it will be 100% vapors. Okay. And it will going be here. Okay. So in order to change this conversion from vapor to liquid, जो हमारा basic criteria है, that is about when the gas is compressed above its critical pressure and cooled below its critical temperature, then we can convert it into liquid. Now, once you say this, when he asked you about the principles of refrigeration compressors and AC, okay, this is similar for AC also. Okay, so he will ask you now, next question will be, what is this critical temperature and what is this critical pressure, right?
So temperature
The
is
temperature
it is the maximum temperature above which a gas cannot be liquefied.
It is, sorry. हाँ बोलो, एक बार दोबारा बोलो.
So pressure, critical pressure, it is the minimum pressure below which a gas
पहले
cannot be
maximum बोला था.
liquefied.
पहले
तो वो
maximum बोला.
टेम्परेचर का बता रहा था.
हाँ, okay. It is a minimum That's why I asked you to say it one more time. Minimum pressure
below
which
which
gas
cannot be liquefied to
cannot
its previous, like, yeah.
be liquefied. Okay. It is a minimum pressure below which a gas cannot be liquefied. Okay. Then what is critical temperature?
This is a
The
maximum
maximum
temperature.
temperature above which
Yes.
a gas cannot be liquefied.
Yes. The temperature. So it is a maximum temperature at or above which a gas cannot be liquefied irrespective of pressure applied. Okay, जितना मर्जी pressure दो, gas will not be able to liquefy. Okay, so these two conditions has to. Is it understood what I'm saying, guys? Are you able to relate what I'm saying? The first principle is regarding your thermodynamics law, second law, part B. Okay, and that is we have to do some work, and that work is done on the compressor. Second, it is saying a gas is compressed above its critical pressure. Okay, and cooled below its critical temperature, then only we will be able to liquefy it. Okay, then critical temperature, cooled below critical temperature. You see the critical temperature, it is a maximum temperature at which or above which the gas cannot be liquefied. So मुझे इस critical temperature के range से नीचे ही रहना है. Do you agree? In the system
Yes, sir.
I have to keep my refrigeration, जो refrigerate मेरा है, refrigerant जो मेरा है, okay, that temperature should never cross in the cycle जो भी उस critical temperature है उस refrigerant का. For example, suppose I have a refrigerant HFC 134A, okay, and its critical temperature is, for example, these are not the correct values, 100 degrees Celsius. So in the complete cycle, there should be never a time should come when the temperature of my refrigerant should cross 100 degrees Celsius. Do you understand what is critical temperature?
Yes, sir.
Okay. If it reaches 100 degrees Celsius, this refrigerant will never be able to, we will never be able to liquefy. Liquid state में कभी ला नहीं पाएंगे उसको. Is it understood? कूलर में जितना
Yes,
मर्जी
sir.
आप कूलिंग करो, ठीक है, सी वाटर से कंडेंसर में, how much you want to do cooling, you can do it, but it will never be changing its state to liquid.
वो
सर ये
वेपर
क्या
नहीं
लिखा
रहेगा
आपने?
गैस में.
कैन नॉट बी लिक्विफाइड
Irrespective
irrespective
of
of
Irrespective of.
pressure applied. Irrespective of pressure applied. Okay. This is pressure, PR. Is it okay? The first two parts.
Yes, sir.
yes sir.
The next one is, these are all the principles. When he asks you about the principle, recently the question पूछा था, but you have to explain it. Okay. So आपको ये सारे principles बताने पड़ेंगे. These all principles it works on. When liquid convert into gas, it absorbs latent heat of evaporation from surroundings. Now, where it is happening? If I talk about, suppose this is my evaporator, okay, and this is the room that I'm cooling, suppose, right? This is the room, suppose I'm cooling. Suppose this is meat room. So when the refrigerant is going to flow through this evaporator coil, it will be coming in contact with the air in the meat room. Okay. And what that air will do? Air will try to evaporate my refrigerant Okay, so
Yes,
if यहाँ से your liquid refrigerant was coming, I want to make sure that here my vapor refrigerant leaves. That means completely the refrigeration effect or the coldness of my refrigerant is utilized, right? So when a liquid is converted into gas, so यहाँ पे liquid है and it is converting into gas, right? Vapor is gas.
yes, yes, sir.
Okay, it absorbs latent heat of evaporation from the surroundings. Surroundings is what? Your room.
Room.
Okay, we will discuss about this latent heat of evaporation kya hai in the after some time. Okay, so is it understood this part?
Yes, sir.
Okay, so the next principle is when pressure drops, boiling point or boiling temperature, will it drop or increase?
It drops.
The drops.
For example, your fresh water generator, आप vacuum create करते हो. When the vacuum is created, your boiling point of your what you say water
Fresh water.
drops and it is getting
Yes, sir.
evaporated even in your jacket water temperatures, right?
Yes, sir. Yes, sir.
So here also this principle will work. When the pressure will drop, the boiling point or the temperature also drops. Okay, we will see later on कहाँ पे act कर रहा है. Okay, then the fifth one, which is very important, is RAC, that is refrigeration air compressor cycle, conditioning cycle. Okay, works on is a reverse Carnot cycle. Okay, now this reverse Carnot cycle is an ideal cycle. Okay, it ideal cycle है. We cannot achieve a ideal cycle. That is why we are able to जो उससे हम suppose for example when somebody is asking you to make some goals and all, they will tell you always make your goals higher, right? ताकि when you're trying to achieve it, you उसके आसपास पहुंच सको, isn't it?
Yes, sir.
ठीक है. So here also, if this is your reverse Carnot cycle, the cycle we will be able to achieve, that actual cycle that we will be able to achieve, that is vapor compression cycle. Okay, we will discuss this one by one now. Okay, vapor compression cycle. Okay, so let us discuss first of all RAC. If is this much is clear to you, can I move forward? Principles, bolo guys.
Yes, sir.
Can I move forward with your explaining what is RAC? Sorry, reverse Carnot cycle.
Sir, is reverse Carnot cycle and vapor compression cycle both same?
No, if your reverse Carnot cycle is an ideal cycle. Okay, I told you the reverse Carnot cycle is an
Ideal
ideal
cycle.
cycle,
Ideal
okay,
cycle.
which is not possible to achieve in real life. Is it clear?
Okay, sir. Yes, sir.
So your चलो मैं लिख देता हूँ इसको. This reverse Carnot cycle now this reverse Carnot cycle, first of all Carnot cycle आ रहा है. Where do you see Carnot cycle? Carnot cycle is used in heat engines.
Heat engines.
Heat
Yes, sir.
If you reverse it, then that cycle we are using in your refrigeration cycles. ठीक है, refrigeration में हम उसको use करते हैं. Okay, now reverse Carnot cycle, it is a theoretical ideal cycle. Theoretical itself means it is theory में possible है,
Not
right?
possible. Possible. Yes, sir. Practical.
Practical it is not possible. ठीक है, it is a reverse Carnot is a theoretical refrigeration cycle that operates with maximum efficiency. Okay. Now, maximum efficiency also it is, you know, is not possible, right? You will be having certain
Yes,
losses
sir.
and all, isn't it?
Losses, yes, sir.
So the practical implementation of this cycle is known as your vapor compression cycle. Okay. Practically, what we are able to achieve is vapor compression cycle. Okay. In real world, we will not be able to achieve the ideal cycle, but with some losses and all, what cycle that we are able to achieve, that is known as vapor compression cycle. Is it understood? For example, if I tell you aim to achieve, ऐसे पढ़ो कि you clear all 4 orals in one shot, but when you're trying to study, maybe you are able to achieve 3, right? 3 पेपर एक बार में निकाल लिए, isn't it? So
Yes,
I'm still able to achieve something, slight
sir.
less maybe, but still good enough, right? So that good enough is your vapor compression cycle, because ideal cycle we will never be able to achieve. Is it clear?
Yes, sir.
Yeah. Okay. So the first cycle that we are going to discuss is your reverse Carnot cycle.
Just like polytropic in air compressor cycle.
Yes, adiabatic process and all those
Yes, sir.
process, right? So those
Yes, sir.
are not theoretical, they practically not possible,
Practical.
isn't it?
Yes, sir.
Yes, sir.
So if we discuss about your reverse Carnot cycle, so the PV diagram of the reverse Carnot cycle I will draw. Normally, they will not go in depth with your reverse Carnot cycles, but they will sometimes ask you, okay? Or maybe in returns, they can ask you. In class 2, they ask all these things, okay? PV. So this is 1, 2, 3, 4. So 1 to 2 is reversible adiabatic compression. Okay. 2 to 3. You can say the vapor compression cycle is based upon the reverse Carnot cycle. ठीक है ना? Reversible isothermal
So thermal.
compression. Then 3 to 4 is reversible adiabatic
Polymetric.
expansion. Then 4 to 1 is reversible adiabatic, isothermal
Isothermal.
expansion. Now, from this reverse Carnot cycle, they will ask you what is COP. COP is known as coefficient of performance. Okay. So somebody asks you how, what is a coefficient of performance, or they can ask you what is COP when they will be specifically talking about your refrigeration cycle. So it is coefficient of performance. Okay. And that coefficient of performance formula is derived by the RAC cycle. Okay. That's why I'm taking it. Otherwise, class 2 mein it is important. Okay. So this is regarding your PV diagram. Now, similarly, I can draw it a diagram, TS diagram, that is between temperature and your entropy. And these diagrams
Sir,
are
can you
asked.
scroll up? I want to take screenshot, sir.
Yes, yes, yes.
Yes, sir. Thank you, sir.
So these diagrams are asked to you in written, huh? Okay. they will ask you to draw TS diagram and PV diagrams.
सर ये कभी एंट्रोपी समझ ही नहीं आई सर,
Don't
होती
worry.
कैसा है एंट्रोपी?
Wait, hold on. Let me draw it first. This is your 1, 2. That is 1 to 2 is reversible adiabatic process, right? One, 2, 3, 4, 4 to 1. And this is entropy, this is temperature. Can I write it as T1 equals to, sorry, T1 equals to T4? Do you agree? Here, in this line, T1 is equals to T4.
Yes, sir.
If my y-axis is temperature, दोनों का temperature same है, right? So here T2 equals to T3. Agree?
Yes, sir.
In the bottom hand side, if I say entropy, so
2, 3 equals to
S3
T.
equals to
S3 equals
S4, and here S1 equals to S2.
S2.
Okay. Now from 2 to 3, okay, what is 2 to 3? So here in 2 to 3, what is happening? I am rejecting the heat.
So which diagram it is? TS diagram.
TS diagram between
Temperature
T and S.
entropy.
Yes, TS diagram.
Okay.
ऊपर वाला PV diagram है, this is TS diagram. Okay, this is heat rejected, and here it is heat added.
Addition.
Okay, heat added क्यों? Because in your evaporator, the atmosphere heat is added into the system, right?
Yes, sir.
That's why the atmosphere is getting cooled.
Yes,
Agreed?
sir.
All right. Now from this diagram, this TS diagram, what is the heat added here? So heat added will be the area
Latent heat of
under
object.
1, 4. If I have to name these, I will name this, for example, 3 dash. इसको name कर देते हैं 2 dash. ठीक है? So 1, 4, 3 dash and 2 dash. So this is the area under which my heat is added. Do you agree?
Yes, sir.
Okay. And what is the area under the curve? Area under curve हम क्या बोलते हैं? किसको बोलते हैं?
Work done,
Area,
sir.
Work done on the
Work
system.
done. Work done.
Okay. Area under curve is work done. Very good. So this is normally work done. Okay. So heat added is area in this particular blue region, shaded region. Okay. Let me just erase it for now. Okay. So what it will be? Length into breadth. That will be. Also you can, अगर इस formula से आपको confusion होगा, you can also call it as length into breadth or change in entropy. Okay. Change in entropy is heat transfer. ये फॉर्मूला है हीट ट्रांसफर बाय टेम्परेचर. सो हीट ट्रांसफर का फॉर्मूला क्या हो जाएगा? टेम्परेचर इनटू चेंज इन एंट्रोपी,
Yes, sir.
राइट? Cross multiply, huh? I
Yes,
can
sir.
write it as like this. Do you agree?
Yes, sir.
Okay. So यहाँ पे लेंथ एंड ब्रेड्थ वाले फॉर्मूले से भी निकाल सकते हैं सेम चीज, ठीक है. So it will come as the length will be T1 and the breadth is change in entropy. That is, अगर इस फॉर्मूले से देख लो नहीं तो इस फॉर्मूले से देख लो, whatever it is comfortable with you. Okay. So length is temperature, the breadth is change in entropy. So that will be T1 minus T1 is greater ना, so पहले आएगा, ठीक है. T1 minus T4. Sorry, S. So S1 minus S4. That is change in entropy, right? इस फॉर्मूले को ही लिख रहा हूं मैं. Heat transfer is your heat added, ठीक है. Transfer can be heat added, the transfer can be heat rejected, isn't it? The formula is temperature into change in entropy. Okay, so change in entropy in this particular region is S1 minus S4. Do you agree?
Yes, sir.
Okay, and you know that I can also write it as T1 is equals to T4. Do you agree? S1 is equals to S2 and S4 equals to S3. Can I write it as like this also?
Yes, sir.
Okay, you can see it over here, these parts. S1 is equals to S2, S3 equals to S4, T1 equals to T4, T2 equals to T3. From there, I can write it as like this also. Do you agree?
Yes, sir.
Okay, so this is your heat added. Normally ये सब नहीं पूछेगा आपसे, ठीक है. This is class 2 level, but still I'm telling you to how to find out your COP, because COP they will ask you. Okay, then the next is heat rejected. What is heat rejected? So heat rejected will be given by the, I will
3,
remove
2.
this shaded region. Okay, इसको निकाल देते हैं. So heat rejected will be, let me take blue color. Okay, will be this. This is your heat rejected. Two, three, 3 dash, 2 dash. That will come on. इसका फॉर्मूला क्या बनेगा? Change in entropy is temperature into change in entropy. That will be temperature will be, for example, I can write it as T3 and change in entropy will be S2 minus S3. Okay. Also, I can write it as T3 is equals to T2, S2 is equals to S1 and S3 is equals to S4. Okay. So this is my heat rejected. Now, what is work done? Can I say work done is heat rejected minus heat absorbed? Okay. This is work done formula. Okay. कितना heat reject किया to amount how much heat has been absorbed. Okay. Where I am rejecting the heat? I am rejecting the heat in condenser.
Evaporate.
Condenser. Reject कर रहे हैं हम heat को.
Yes, yes.
Okay. Isn't it? All right. So heat rejected, it is, for example, I'll take this one. Okay. If I'll take this one, that is T2 S1 minus S4. अभी अगर आपको समझ नहीं आ रहा है तो आप सोचो, इफ वर्क डन क्या बोला था, एरिया अंडर द कर्व, राइट. सो हीट, अगर इस हीट रिजेक्टेड में से इफ आई रिमूव हीट एडेड, ठीक है. सो डोंट यू थिंक अगर ये निकाल दिया पहले वाले से, सो आई विल बी रिमेनिंग विद दिस वन. डू यू एग्री? एंड दिस इज वर्क डन. इस पूरे बॉक्स से if I'm removing this part, the blue part, bottom one, okay, light blue color, will I get this dark blue color region? And that is my work done, right?
Yes, sir.
Yes, sir.
Okay. So this is heat rejected is this one. What is heat added? I can, sorry, I can write it as this one. तो इसमें एक बार देखना दो मेरे को. I have taken S1 minus S4, right? ठीक है. So this is my heat added. So if I write it down here, minus T1 sorry, S1 minus what is what क्या था? S1 minus S1. So can I write it T2 minus T1 S1 minus S4 mathematics?
Yes, sir.
बोलो. Yeah. So coefficient of performance क्या होता है? What is coefficient of performance? Coefficient of performance is heat absorbed divided by work done. Or if you have to, or you have to define it as in other way, you can also call it as amount of what you have to say to surveyor. If he asks you what is coefficient of performance directly, what you can say is you can tell him amount of heat extracted from. कहां से एक्सट्रैक्ट कर रहे हो?
Evaporator. Evaporator.
किसी रूम से एक्सट्रैक्ट कर रहे हो, राइट?
Yes,
आई
sir.
एम टेकिंग एग्जांपल ऑफ रीफर रूम. ठीक है. ऑब्वियसली थ्रू योर इवेपोरेटर. ओके, जो आप बोल रहे हो वो भी गलत नहीं है. फ्रॉम अ रूम थ्रू इवेपोरेटर, आई कैन राइट इट लाइक दिस, थ्रू evaporator, okay, divided by work done on the system. Yes. Okay. So what is heat absorbed here? Heat absorbed is in your upper part. Okay. Heat absorbed is T1 that was heat absorbed. T1 S1 minus S4 divided by net work done is T2 minus T1 S1 minus S4. So will this cancel out with each other? Can I cancel it out?
Yes, sir.
So my COP formula will become T1 minus T2 minus T1. Sometimes they will ask you this in written. Sometimes, okay. Mostly in class 2 level, they will ask you to define it. But in class 4 level, they will be only interested is what is coefficient of performance. And you have to tell him it is amount of heat extracted. Color ज़्यादा dark हो गया. Amount of heat extracted from the reefer room, okay, through the evaporator divided by how much work we have done, okay, by through our compressors to achieve it. Is it clear? Bolo guys, is it clear? And how I have driven
Yes, sir.
Yes, sir.
your formula also for it. Formula also I have derived. This is the formula for it. Okay. Now, I told you that your reverse Carnot cycle is an ideal cycle. We will never be able to achieve an ideal cycle. So the cycle that it follows, it is close to reverse Carnot cycle, or you can say it is based on the reverse Carnot cycle, but it is not exactly a reverse Carnot cycle, isn't it? So now this is important for you. So somebody said in the start of the class, vapor compression cycle, right? So it works on vapor. This is the actual practical cycle that your RSA is working on. Okay. Okay. For this particularly, they will ask you draw the pH and TS diagrams for vapor compression diagrams, because this is important. Okay. They will ask you draw diagrams for pH. What is H? H is enthalpy. Okay. And TS diagram. Okay. So I'll draw these diagrams for you first.
No, sir.
See, normally all the sessions that I'm taking, it is a combined written and your orals. ठीक है? दोनों साथ में ही हो जाएंगे तो बढ़िया है, right?
सर सीओपी में क्वेश्चन पूछा था सर, हाउ टू इम्प्रूव सीओपी करके।
How to improve
सीओपी।
COP. अभी आपको फॉर्मूला दिख गया. ठीक है? How will you improve it? Now suppose
इंक्रीजिंग
if
T1।
my this thing top, ठीक है? Top it is getting increased. Will my COP increase or decrease?
Increase, sir.
If
इंक्रीज।
I'm able to extract more heat, so it will increase, right? So in time, अब इसमें क्या क्या प्रॉब्लम्स आ सकता है? आपके इवेपोरेटर कॉइल्स चोक हो सकते हैं, द फिन्स कुड बी चोक्ड, योर फैन कुड बी चोक्ड. सो आई विल कम टू ऑल दोस थिंग्स लेटर ऑन. ठीक है ना? इट इज you have to just imagine how my the numerator here can be reduced. If it can be reduced, the opposite of it, if I increase it, then my COP will increase. Do you agree?
यस सर।
Suppose karo, if my evaporator coils are choked, okay, or if evaporator coils में कैसा रहता है ना आपका, like these are the coils and there will be fins, just like your air compressor में I told you about the, किसके बारे में बोला था?
एयर को
एयर
What
कूल्ड
was
कंप्रेसर।
एयर कूल कंप्रेसर
रेडिएटर?
से
रेडिएटर बोला था, रेडिएटर में आपका
यस
फिन्स
सर
रहता है, राइट?
यस
So here also these evaporator coils, from the inside your refrigerant is flowing, and from outside a fan is throwing air onto this tubes. Okay. And this air will, it will reject its heat into your refrigerant, and refrigerant will become hot, isn't it? That's why it is changing state also from liquid to vapor. Okay. Now suppose if these fins are choked somehow with dust and all, will you get that much of COP? आपका अभी amount of heat extracted from the reefer room will drop, isn't it? नहीं समझ आ रहा है?
आ रहे सर।
Tell me guys, not unable to understand or this? Suppose for example, एक example दे रहा हूँ, I will discuss it later on actually. ठीक है? COP, how you can improve it. Okay. Suppose COP is basically, with your definition itself, it is amount of heat extracted from the reefer room through evaporator. So if any problems comes to your evaporator, what is evaporator? Coils हैं, okay? Like this coils are going, and from within your refrigerant is flowing. Okay. These coils are having fins to increase the surface area, right? Fins are always provided to increase the surface area. So these are your fins, and there will be one fan here. Okay. This fan will be throwing your room air onto this fin, onto these tubes, the evaporator tubes. Agree?
यस सर।
From which your refrigerant is flowing. Okay. Guys, are
Yes,
you
sir.
with me?
Yes,
Just
sir.
Yes,
like
sir.
just like your air compressor, right? Now this air will be hitting on these tubes, and then only it will be transferring its temperature to your refrigerant. And that's why a liquid refrigerant will become hot and it will go
Got it.
out as a gas state. Agreed?
Yes, sir.
And when in doing so, this air will become cold, the room air. Do you agree?
Yes, sir. Yes, sir.
Okay. For example, suppose these fins are choked. Take a dust and all for all those things. These fins are choked. What is going to happen? My performance is dropping or increasing?
Dropping.
Drop कर रहा है, isn't it? My performance will drop. So what I need to do in order to improve its coefficient of performance, I need to clean it. Agreed?
Yes, sir.
जैसे आप अपने कंप्रेसर्स का एयर कंप्रेसर्स का क्लीन करते हो कूलर दिस व्हाट यू से the cooler you clean it, right? For what purpose? To increase its efficiency? Do you guys relate to me what I'm saying? This is
Yes, sir.
one of the step, okay? And other steps I will discuss later when I will tell you about your cycle first of all. Huh? Sorry, components we have to understand what all the components that are coming in your complete cycle, then we will understand. This is one example I have given you. Is that example understood to you or not?
Yes,
The
sir.
one who asked the
Yes, sir.
question.
Yes, sir. Yes, sir.
Yeah, okay. We will discuss it later on. Don't worry. Okay. Now the pH diagram. Okay. So this is your where your evaporator comes. Guys, you all know what is evaporator, right? Do I need to explain it? What is evaporator? Anyone who does not understand? I told you there are four basic components. Compressor, okay? Compressor will compress your refrigerant, okay? Then there will be condenser, agreed? Condenser will make it into the liquid state, your refrigerant. And then there is coming what? Your expansion valve. And then evaporator. Evaporator and condenser are both heat exchangers. Heat exchangers, I think everyone understood, right? What is heat exchanger? Shell and tube.
Yes, sir.
Okay. Heat exchanger. It is also a kind of an heat exchangers only, condenser and your evaporators. Okay. It is actually a heat exchanger. Okay. So this is the diagram for your pH diagram. Okay. Now, I use maybe red color. If you take the note from here, this line from here to the other end, this line is known as saturated vapor line. Okay. This line from the other end, now this is known as saturated liquid line.
So from where to where it is?
बीच में एक पॉइंट लगाया ना, वहां से लेके नीचे तक, ठीक है, till here.
Till okay. Okay.
So I can say that if this particular region, okay, I will use a bigger one. Okay, this particular region is where my Now this particular region is, everything here will be in vapor state. Do you agree? 100% vapors. Bolo. If that is saturated vapor line, any cycle that is coming out of it, that means यहाँ पे vapors है. Do you agree?
Yes, sir.
Yeah.
Yes, sir. Yes, sir.
Now whatever will be on the opposite hand side, if I'll take it as in light blue color, now this part is what it is telling me,
Liquid.
liquid. Oops, थोड़ा सा गलत हो गया. This is completely liquid. 100% liquid, huh? Liquid. But what it is in between?
Liquid plus vapor.
Yes, it will be liquid plus vapor. जो इसके बीच में था. This will be liquid plus vapor. So अभी इस डायग्राम के हिसाब से देखो, if I'll start from, for example, I will start from a compressor. So at compressor, is my liquid compressible? These compressors are normally your piston type compressors. So is it allowed if any
No, sir.
liquid comes to your compressor? No, right?
No, sir. No, sir.
Right? So only vapor should come. So you will see the compressor is basically in the vapor states always, cycle, right? After the compressor has compressed your refrigerant, okay, the gas, it has compressed it, it will be still in vapor state, right? After that, it is going to condenser. Agreed?
Yes, sir.
I will just name it. Number 1 to 2 is your compression cycle. Number 2 to 3, it will be your condenser cycle. Number 3 to 4 will be your expansion cycle. Okay. I will draw one more diagram here just so that आपको अच्छे से समझ आ जाए. This is evaporator. अच्छे से बनाते हैं. This is important, guys. हाँ, ये पूछते हैं. This is the basics of RAC. ये समझोगे, then you will be able to answer a lot of cross questions and all. And if somebody is not able to understand, please right now let me know. अगर कुछ नहीं समझ आ रहा है, ठीक है? ऐसे आगे बढ़ने का कोई मतलब नहीं रहेगा. This is my compressor, and then I have a condenser, and then I have TEV, thermostatic expansion valve. Okay, this is number 1, number 2, number 3, and number 4. So 1 to 2, always your refrigerant will be in your vapor state. Then from 2 to 3, it will reach to condenser. Agreed? And in condenser, what it will do?
Yes,
The
sir.
refrigerant that is flowing inside, it will reject the heat. Heat निकालेगा अपनी, पानी का टेम्परेचर बढ़ेगा, whatever the cooling media is, right? That is what condensers does. ठंडा करता है ना आपके मीडियम को.
Yes, sir.
Yeah. Any cooler, what it is doing? It will try to cool it down, the whatever it is coming. Right now, my refrigeration that it will be coming, the refrigerant that it will be coming from here, that will be hot. If I want to cool it down, I will send it to the condenser. Condenser will reject the heat. Okay, uska heat निकालेगा, and it will try to convert it into liquid. But you can see till here to here it is in liquid plus vapor state. यहाँ पे agree? In between this curve, saturated vapor line and your saturated liquid line, in this part, particularly, if I'll shade it, अगर नहीं समझ आ रहा है, यहाँ पे it will be in liquid plus vapor state. But
Yes, sir.
I want it to convert it into 100% liquid. So for that particular region, I am providing certain degree of subcooling, and that is this part. from here to here. Color is very bad. So this is from this point to this point. Now this is known as subcooling. Is it understood? Subcooling देना पड़ता है so that no what do you say? No vapors goes ahead, only liquid state it should go, right? Where is it? This one here. So this line is particularly for saturated liquid, and this one, it is subcooling. Subcooling is given in your condensers, okay? So that temperature drops further down more than the saturated point. Is it clear?
So how is this subcooling attained? With the help of seawater, right?
I will tell you later. Okay?
Okay, sir.
Subcooling is a design feature. Suppose karo, for example, this is my condenser tubes. Okay, this is my condenser. So here, what is flowing inside the condenser outside? यहाँ पे क्या flow कर रहा है? In this part?
Water, seawater.
Seawater, right? Agreed. Seawater, or your if your LTHT system is there, then your LT water.
Fresh
Okay.
water. Yes,
Sea
sir.
water. अभी के लिए sea water मान लेते हैं. ठीक है? Sea water is flowing out and this is out. Okay. Now the refrigerant is flowing from inside is right now at what state? At the inlet in the condenser? Vapor state, right?
Yes, sir.
Compressor से निकल के vapors में आ रहा है, right? Suppose by till reaching till here, it has already converted into liquid. Okay. After it is rejecting the your heat to your water, it has already reached in a state in which it has already converted into liquid. After this, whatever extra coil is there, that is provided for subcooling. That means the temperature should further drop down. Is it understood? Just
Yes,
to
sir.
make sure that no vapors goes forward. Is it clear?
So basically we increase the area.
Yes. You are increasing number of tubes, and accordingly you will be
Do
doing
those
subcooling.
subcooling.
Okay? About 5% of subcooling is done. ठीक है? अगर और डिटेल में जाना है, so about 5% of subcooling is given in your condenser itself. Is it clear? Now you can
Yes,
see, agar if I take the tapping from here and I will give to expansion valve, don't you think my liquid and vapors are going? यहाँ in this region it is liquid and vapors, right? देखो, do you agree?
Yes,
Yes,
sir.
sir.
That is why I have to provide a subcooling to it so that it should change 100% into vapors. The refrigerant that it is flowing in the system should change to 100% liquid state. Is it clear?
Yes,
Bolo,
sir.
is it
In
clear?
normal, sir. Yes, sir. But in normal, this domestic refrigeration system, how this subcooling is attained?
Because of the construction of your condenser.
So वहाँ पे cooling कैसे होता है sir? जैसे we have sea water over
Cooling is
here
done
in
by
the.
your seawater, isn't it? Seawater or
Yes, sir.
your fresh water, whatever system is there on board your ship. But उस condenser का length कितना है and how much capacity it is. If it is more than little bit than what is actually required, okay, then that means I'm giving some certain degree of subcooling to it. जैसे मैंने आपको explain किया, I
Yes,
have a
yes, sir.
tube, है ना? I have a tube, और यहाँ पे तक पहुंचते पहुंचते completely आपका जो भी मीडियम था, that in this case it is refrigerant, okay, and यहाँ पे वो vapor state पे आ रहा है, till here it reached, it already convert into liquid. So whatever now remaining tube is there, that will act as a subcooling media. It will cool it further
Yes, sir.
and make sure
Yes,
that no vapors are coming out of condenser.
yes,
Is it clear?
So I understood that, but I was asking that in domestic refrigeration system, how we cool, like we use cooling media as this
See,
seawater
if you have LT-HT system on board your ship, okay, then you will be using LT water. ठीक है, fresh water use करते हैं. If it is sea water system, then you will be using sea water. Condenser use होते हैं.
Yes, sir. So
Yeah.
that's what I'm asking. In domestic refrigeration, how we use, what we use.
Domestic refrigerant it is. अच्छा, ये जो घर वाले एसी को पूछ रहे हो.
Yes, sir. Yes, sir.
तो
Yes, sir.
that is आपने अपने देखा होगा. You have AC in your room, in your house.
Yes, sir.
हाँ, तो आपने देखा है एक तो one unit is inside your room. Okay, that is your what?
Evaporator.
Evaporator.
That is your
अच्छा,
evaporator.
is
एक
that
ऊपर भी
air
लगा है.
cooled?
ऊपर एक ऊपर लगा हुआ है छत पे. In which there is a one fan is there.
Yes, sir.
A fan will be there, right?
Compressor or condenser.
Okay, so it यहाँ वहां पे with air it is cooling down. ना वहां पे condenser में the cooling media is air. जो आपका
Okay, sir.
एटमॉस्फेरिक एयर है उसी से वो कूल कर रहा है उसको. ओके, एयर
Okay, sir.
फेंकता रहता है वो आपके कंडेंसर ट्यूब्स पे. ठीक है, दे विल बी वन फैन ऑल्सो. आप देखो उसका एक लाइन. एक और दो चीजें होती हैं आपके घरों में, राइट? One is installed in your cabin, that is your split AC. That is a combination of evaporator
And
and
TV.
TV. Okay, so एक compressor वाली यूनिट भी लगी रहती है in which you have compressor and condenser, and there will be one fan also which will be throwing air to your condenser. Okay, so that cooling
Yes, sir.
करने के लिए. ठीक है.
Yes, sir.
Okay, so वहां पे air medium है, air. All right. Now where was I? So is this understood? First of all, diagrams. What is subcooling and how it is achieved also? Guys, till point 3 it is
Yes,
understood.
sir.
यहाँ तक सबको समझ आ गया?
Yes, sir.
Yes, sir.
Yes.
All right. Now the next is, after this, it is going to the expansion wall. Okay. This expansion wall we will discuss in very thoroughly later on. Okay. It is going to the expansion wall. Expansion wall, I told you, it will convert some maybe 5% into, right now it is at expansion wall, what it is coming here? 100% liquid. Agree?
Fully liquid. Yes, sir.
100%.
After expansion wall, it might change to 5% gas and 95% liquid. ठीक है, यहाँ पे expansion wall में you can understand expand. Okay, it is expanding it. Okay, I will explain you later on in very detail what is expansion wall, how it is working. For now, just imagine this, and you can see यहाँ पे gas आ गया. So in what state it will be coming? The number 4 point, it will come in liquid plus vapor state.
Yes, sir.
Do you agree? Yeah. And
Yes, sir.
after evaporator, when it is going from the evaporator, outlet of the evaporator, I want to achieve which is 100%
Vapor.
vapor.
Yes.
Because I don't want liquid to go into my compressor, otherwise piston टूट जाएगा, isn't it? Do you agree?
Yes, sir.
Yes, sir.
So, in order to provide this 100% vapor, I am giving something which is known as superheat. Just like in your condenser, I'm giving subcooling. Here I'm giving superheat, and superheat is a design feature of the evaporator itself. Same funda. Okay, same funda. This is the coil. When your 95% liquid is going into it, it will change in this much area itself. It will change to 100% vapor. Whatever is remaining afterwards, that is superheat. Is it clear, guys?
Yes,
Okay.
sir.
Number at one point only your evaporator cycle is finishing, right? So उससे पहले ही आपका superheat is coming. Is it understood?
Yes, sir.
Okay. All right. So this is regarding your pH diagram. Will you be able to explain the pH diagram if it is asked?
Yes, sir. Sir.
All right. Okay. Similarly, they will sometime ask you to draw a, इसमें explanation नहीं मांगते, they just ask you to draw TS diagram also. Okay. So the TS diagram for your refrigeration cycle is this one. This is obviously saturated vapor. This is saturated liquid. Diagram, TS diagram comes like this. So this is 1, 2, 2 dash, 3, 4. So 1 to 2 is obviously your compression. Okay. Then from 2 to 3 completely it is your condenser part, 3 to 4 expansion part, and 4 to 1 is your evaporator part. Okay, just draw this diagram because they will ask you to draw TS and this diagram. ठीक है, अगर इसको और ज्यादा अच्छे से बनाना है, like completely you have to draw it correctly. So this 3 point will go somewhere here and then it will come. ठीक है, that is depicting your subcooling also, and this is also going to extend slightly ahead from this number 1 point. Okay. Ah. Okay, I'll show you maybe यहाँ पे होगा कहीं ना कहीं. Hold on. TS diagram of refrigeration cycle. See, this is the one that I've showed you, है ना? Isn't it? Guys, you can see this, right?
Yes, sir.
This is the one I've showed you. But if you want much more in a better way, then this is the one जहाँ पे आपको superheat and uh, about your
Subcooling.
subcooling भी दिया होगा. Let me just save it. Okay. TS has to be saved. I'll just बनाने से better है. I'll just paste it over here. So actual diagram will be looking like this one. सेम थिंग ही है, ठीक है, जो हमने अभी पढ़ा है. ठीक है, नथिंग मच डिफरेंट हियर. What is it? सेव नहीं हुआ क्या? ये रहा. Okay. ठीक है, इतना काफी है. जूम. This is your TS diagram. Okay. Is it clear? So you
Yes,
can see
sir.
the subcooling part. You can see the superheat part. ठीक है. Subcooling compression diagram is this one. So the one that I'm going to indicate around that will be your actual cycle. Okay, from here to here. Then from here to this is condenser cycle. Then subcooling, and this, And from here, this is the actual cycle, and center part is a normal one. Okay. So this is your TS diagram. Okay. All right. Can I move
Yes,
forward?
sir.
बाकी चीजें सुन
Yes, sir.
बोलो।
Sorry, for superheat, we used we have thermostatic expansion valve, right? That will maintain
For
around 5
superheat,
to
for superheat,
for maintaining superheat.
hmm.
We have a TV. We have which will maintain
No, no,
about
no,
5 to 6%.
no, no. सुपरहीट के लिए टीवी नहीं है। सुपरहीट इज अ डिजाइन फीचर ऑफ माय इवेपोरेटर, है ना? इवेपोरेटर के साथ ही आ रहा है। डोंट यू थिंक फ्लो टू वन इज इवेपोरेटर, राइट? आप देखो, अगर इसको मैं ए डैश कर लूं तो ए डैश टू वन इज सुपरहीट। एग्रीड? So it is a
Yes, sir.
design feature exact only for your evaporator, not related to your expansion valve. Do you agree?
Okay, sir.
All right. Okay. Guys,
And
any other
subcooling
questions till now?
and
Bolo, हाँ,
subcooling
bolo, bolo.
is also a design feature of condenser.
Condenser itself. Okay, nothing else.
Okay, sir. Okay, sir.
Yes,
And
guys.
how we
Anyone?
will calculate that only 5% is
That
like
is
subcooling
decided
is
by the
maintained.
manufacturers. That is decided by the manufacturers, and when they will supply you condenser, they will mention in the booklet like how much is the subcooling is. Okay.
Okay, sir.
Normally, okay, it is 5%. Okay.
Okay, sir.
Just give me a minute. I'll just drink some water and come on.
भाई फंक्शन 4B का क्वेश्चन है तो पोस्ट कर दो यार।
Okay. So any questions till now? बोलो भाई लोग। अभी तक जो पढ़ाया समझ आ रहा है? Everyone, are you able to understand what I've said to you till now?
Yes,
Yes.
sir.
Okay. Any other questions related to this till now? I have 19 guys over here. Okay, 18 actually. So for now, you guys understood what I've said? Okay.
Yes.
All right. So I'll
Yes,
move
sir.
forward. Okay. Now we will understand few small things like what is specific heat, what is sensible heat, what is latent heat, because sometimes this is also asked, okay, in cross question. Then we should be able to tell what is what, okay, and then
Sir,
only
and
we will go to the actual cycle of your RAC and your AC systems. Okay, bolo.
sir,
Somebody was saying something. Yes.
sir, एंट्रोपी के बारे में बताओ ना सर।
Yeah,
And
I will come to that also. Okay, एक एक करके आएंगे सब। ठीक है, specific heat. We'll discuss specific heat, latent heat, all those things we will discuss, and then we will come to entropy, enthalpy. वो भी if you want, I will take it. ठीक है? Okay. So what is specific heat?
Energy required to increase temperature
Yes.
by 1 degree.
Very good. Okay. Energy or your heat required to increase the temperature by 1 degree, right? So I can write it as amount of heat that must be added now what you missed is this to 1 unit of mass of substance. Okay, in order to increase, or you can say in order to increase I'll write it in much better way. Substance in order to cause an increase of 1 unit in temperature. Simple terms, mein, what he has said is absolutely right. If I have a beaker, I have water. Okay. So suppose this water is at 50 degrees Celsius and down below I have kept a burner. Okay. Which is supplying the heat. How much heat I have to supply so that I can change the temperature to 51 degrees Celsius. Is it clear? This is known as specific heat. Understood? Bolo guys, is this understood? Amount of heat that must be added to 1 unit of mass of the substance in order to cause an increase of 1 unit in the temperature. That means 1 unit kitna hua? 1 degree. If I'm talking about degrees. Okay?
Yes, sir.
Then sensible heat. Sensible heat is anything that you can sense. Okay? That you can feel and that you can measure in the thermometer. Okay? Like suppose if I'm trying to heat the same water, this is water, and I'm heating it. This is heat. Okay, burner. If I'm heating it, whatever the temperature rise will be there, till 100 degree, I will be able to measure it. What will happen after 100 degrees Celsius? It will change the
Lat
state, isn't it?
latent.
Okay,
Yes, sir.
so that will become latent heat. Okay, so the amount of heat that you can sense, that is your sensible heat. Okay, so I will write it as okay, when any substance is heated, its temperature increases. As the heat is added. Okay. This increase in heat or this increase in the temperature this increase in heat is known as sensible heat. Sometimes they are asking small questions. So sometimes they will go to what is specific heat, what is sensible heat. Then you have to explain it to them. Okay. But you have to mention this heat is called sensible heat, but without change in state. That means it should not change into vapors. Okay? Because if it changes to vapors, then it will become latent heat. Is it clear? What is sensible heat? Bolo guys, is it clear?
Yes, sir.
So I can write it as insensible heat, there is temperature change, but phase remains same. Only temperature will change, phase does not change. Huh? Water से vapor नहीं बन रहा है, isn't it? Now in latent heat, लेटेंट हीट में क्या होता है, टेम्परेचर remains same but phase change. Okay, now suppose if I'm going to heat, okay, if I'm going to heat water, okay, I'm heating through a burner. After 100 degrees Celsius, the water will keep, after, once suppose it has reached 100 degrees Celsius, okay, it has reached 100 degrees Celsius, this temperature is actually known as saturated temperature. Okay, so if I take an example, suppose this line is for 100 degrees Celsius, so this is saturation temperature. Above this it will be superheat, and below this I can consider at subcooling. Okay, ऐसे भी बोल सकते हैं. Later on we will see that, but right now what I'm trying to say is, once you start heating the water, okay, once it reaches the 100-degree point, after that I will be generating vapors. Do you agree? Vapors banega. Water
Yes.
boils at 100 degrees Celsius.
Yes, sir.
Okay, but the water which is there, the temperature will remain 100 degree only. Okay, after 100 degree it will just change the state. Okay, but if I heat it further and this steam gets heated up further, it will reach to superheated steam. यही होता है. Do you agree? When the temperature will rise further more than 100 degrees Celsius, that will be superheated. Is it clear? Guys, tell me.
Yes, sir.
So latent heat is, इतना याद रखोगे, अगर change your temperature remains same but the phase changes, that is much more beneficial for you. Okay, it is the hidden energy which is supplied or extracted to change state of substance without change in its temperature. Even if you boil water and it started generating steam, if the container is open, if a container is open, okay, boiler में it is a different story because it is a closed, enclosed space, right? Closed रहता है ऊपर से. So if I heat the water, okay, and the water has reached to a 100 degrees Celsius, after this, whatever heat I am supplying, that is known as latent heat, because in this the phase change will starts to take place. It will becomes vapors. Okay, but the water temperature will remain same 100 degree. It will not go 101. Is it clear? And the amount of heat that I'm supplying at this moment, it is a hidden heat. I cannot find it out because water ka temperature will remain same. Do you agree?
Yes, sir. Yes, sir.
Okay, so it is a hidden energy which is supplied. Okay, extracted वाला point में भी आता हूँ अभी, to change the state of a substance without change in the temperature. So temperature is remaining 100 degrees Celsius. Okay, and the phase change is taking place. So is it clear? Bolo, is it clear?
Yes, sir.
Now, for
Yes, sir.
example, I will take ice. Okay, so this is ice. It will convert into water. And this will convert into steam. So when I heat my water without the change in temperature, if it converts into steam, this is known as latent heat. How much energy I have supplied? Agreed? Just now what we have seen? Tell me.
Yes, sir.
Guys, tell me. Yeah.
Yes, sir.
But when it will absorb the heat, the ice will absorb the heat, and at that temperature, suppose it is 0 degrees Celsius, at that temperature itself, it convert into water at 0 degrees Celsius. Then this is also latent heat without change in temperature. The phase is changing from solid to liquid.
Yes, sir.
Okay,
But
so
temperature
this,
constant.
yeah, temperature is constant, but the phase is changing. So this is also latent heat. Is it clear? Follow, guys. Is it clear?
Yes. Yes, sir.
Okay. Now, next is your latent heat of vaporization. ये भी इसी से ड्राइव्ड है, ठीक है? The heat required to change the state of 1 unit of liquid at its boiling point, which is means saturated point, into vapor at constant temperature. So here also temperature is same, but my phase is changing, but it is only for 1 unit. Okay? Is it clear? It is same, but the difference here is it is only telling about 1 unit when it will change to vapors, but at a constant temperature. That is known as latent heat of vaporization. Clear? Now I'm using a lot of time a word that is saturated temperature. Okay. Whenever in your RAC terms, whenever you're using this boiling point and all, you will use the term saturated temperature. Okay. So saturated temperature क्या है? The temperature at which the liquid changes its state to vapor. Okay. When the that is in terms of water, it is boiling point, isn't it? This is also known as boiling point. Okay. But for water, we call it as boiling points. But in case of refrigerants, we call it as saturated temperature. Is it understood? It is a temperature in which the phase will change. Okay. Guys, suppose, for example, my refrigerant, okay. Now you imagine one thing, where in my evaporator, suppose meat room it is there. Okay. So what is the temperature that we want to maintain at meat room?
-5.
Minus
Minus
16,
17.
minus 16. ठीक है?
Sir,
ठीक है? Meat room में we maintain around -16. In fish room it is around -19. Okay, 18, 19. Okay. So the refrigerant that will be flowing inside your evaporator in your meat room, okay, it should be, suppose the cut-in temperature is -12 degrees Celsius. That means at -12 degrees Celsius, your cut-in will happen and your refrigerant will starts to flow inside the system. But at -12 degrees Celsius itself, it should be able to evaporate. Do you agree? My refrigerant should evaporate ना, तभी वेपर में चेंज होगा. That means boiling point of my refrigerant should be less, or I can say saturated temperature of my refrigerant should be as less as possible.
No, sir.
बोलो.
फिर से
See,
Maybe no.
कोई भी चीज when it will change the state to another state, or you can say the boiling point, it has to boil ना. This refrigerant has to boil जो अंदर है, तभी it will change to vapor state, right? It was coming at liquid state inside the evaporator. Agreed? 95% liquid.
Yes, sir.
But outlet should be completely vapor state. Do you agree? And in order to become vapor, it has to boil and it has to change the state to vapor. Do you agree?
Yes, sir.
So my saturated temperature for the refrigerant should be high or low?
Should be
कम
low.
temperature
Low,
में
very low.
Very low.
low,
Should be low,
right? It should be able to boil at much lower temperature, and you can see the temperature right now -12 पे भी boil हो रहा है. ठीक है? Is it understood what is saturated temperature?
Sir.
Okay.
Then how it's going to done like -12 degrees? How it is going to evaporate?
That is the point now. Water का saturation temperature is 100, but refrigerant is not water.
Okay,
Isn't
okay.
it?
Yes, sir. I understand.
उसका boiling point कुछ और हो सकता है, right?
Maybe it depends upon the refrigerant what we are using.
Yes,
Property of
obviously.
refrigerant है ना.
This is a property of refrigerant only. ठीक है? उसका saturated temperature क्या है? Similarly, lube oil का saturated temperature will not be 100. 100 डिग्री में आपका lube oil change हो जा रहा है क्या? नहीं ना?
नहीं sir.
Yeah. So everything will have its different saturated temperature, and you should know what is the saturated temperature of it. Okay.
So this saturated temperature is only for boiling point or for freezing point also. मतलब
It is
जब भी
also for
temperature
freezing
कम
point
हो रहा है.
also. Okay. Below my saturated temperature, it will starts to, suppose now if I change it again, I send it to vapors से condenser में भेज रहा हूँ. So there also this concept will come na, saturated temperature. I have to cool it below its saturated temperature. Then only it will, suppose saturated temperature is 100 degree, जैसे मैंने आपको बोला, इससे ऊपर जो भी होगा, that will be superheat. नीचे will be subcooling. So whatever temperature is less than the saturated temperature, the phase change will again take place. Vapor से liquid change हो जाएगा if you cool it below the saturated temperature.
Yes sir.
Okay.
Sir, if the surveyor is asking how we are achieving this vapor state in evaporator, simply we can say by the saturation temperature of the refrigerant what you're using. It's enough to...
आऊंगा उसमें भी आऊंगा. ठीक है, थोड़ा थोड़ा बेस क्लियर करके. ठीक है, आई विल कम टू दैट.
जी सर.
दिस क्वेश्चन यू शुड आस्क मी टुमारो. ठीक है, याद रहेगा आपको?
हाँ सर.
Yeah, ask me this question tomorrow when I will be able to, much betterly, because I have to give you the cycle perspective also. There is a compressor. What is the function of compressor? Now suppose, for example, 100 degrees Celsius is the saturated temperature. ठीक है? Above this, if I give more, the phase change will take place. But now if I have to cool it down, can I cool it down below 100 degrees Celsius? आप पानी का टेम्परेचर क्या है? 30 है, isn't it? 30 degree is able to, or 35, whatever you can take. Okay, 30 to 35 is your water temperature, cooling water temperature in the condenser. So that temperature itself is able to convert the vapor into liquid, and -12 degrees Celsius is able to convert it into liquid to vapor. Do you see कितना difference है?
Sir, but it depends upon the liquid. These are using refrigerant. That is, we are using vapor liquid like for cooling water.
But it is still the same refrigerant, right? So how it can have different saturated points?
Pressure, sir. Different pressure environment.
Yes, very good. It depends upon the pressure. Okay, that is why the main objective of giving a compressor, I can give एक पंप दे सकता था मैं रेफ्रिजरेंट को फ्लो करने के लिए. I have given a compressor to increase its saturated pressure and saturated temperature. Then after compressor, when I'm giving a compressor here, suppose करो यहाँ पे saturated temperature for this refrigerant was minus 30 degrees Celsius. I told you it should be as low as possible, right? To, for a good refrigerant, saturated temperature should be low. But when I send this refrigeration to my compressor, the saturated temperature increases. And suppose it increases to 50 degrees Celsius. Now at below 50 degrees Celsius, if I give a cooling media, it will be able to change the state to liquid. Okay? So this question you will understand tomorrow, not today. Okay? Maybe somebody might have understood, but not everyone will understand at this moment this thing. Once I will tell you the cycle, then I will be able to explain you in much better way. Is it clear?
Yes, sir.
Okay. So this is regarding your saturated temperature. So everyone can relate what is saturated temperature. We never use boiling point when we talk about refrigeration plants. We only use the term saturated point, saturated temperature. And whenever I'm going to use this term, it simply means the boiling point. Is it clear? So can I
Yes, sir.
say if the boiling point of my water is 100 degrees Celsius, so if I give more heat above the saturated temperature, the phase change will take from liquid to vapor, right? Above
Hmm.
saturated temperature, if I talk about water, my phase change will take place from liquid to vapors. Agreed?
Yes, sir.
And below this saturated temperature, which is 100 degree, my phase change will take place from vapors to liquid. Do you understand now?
Yes, sir.
Slightly? Huh? Okay. Right now, I have small time frame. चलो पहले तो this entropy and all I should take tomorrow. ठीक है नहीं तो finish नहीं होगा. Entropy बता देंगे, enthalpy बता देंगे. चलो. Not required, but still. ठीक है. Now, any questions till now?
So
Is
for
the
orals, what we discussed until now. So for orals, they will ask this much deep, like PV diagram and this thing.
no? They will ask you about principles in orals. ठीक है. Principle should be in mind. ठीक है. ये सारा principles आपको whatever 5 points I've given you, these 5 points is the answer when he asks you on what principle your refrigeration compressor works. Recently asked in I think previous month this question was asked. ठीक है. The person who only answered about second law of thermodynamics. I don't know he answered part B or not, but he did not mention other points 2, 3, 4, and 5. So he did not accept it. Okay. In reverse Carnot cycle, you don't need to practice all these things. Okay. But you should know what is coefficient of performance. Okay. This is important. Okay. This derivation, nobody will ask you to drive and all. I have just given you how it is coming. ठीक है थोड़ा सा बताने के लिए ठीक है
सर ये स्टेटमेंट्स बताइए सैचुरेशन टेम्परेचर एंड ऑल सर ये पूछेंगे ओरल्स में
yes this is important they can ask this thing ठीक है now vapor compression cycle mostly they will ask you in writtens okay written में पूछेंगे ये आपसे to draw ts ph diagrams पूछते हैं ना ऐसी चीजें पूछते हैं right
हाँ सर वहां पे पूछते हैं सर ये वाली चीजें
हाँ so this is for your written ठीक है this particular vapor compression cycle का ph diagram and the ts diagram is it is for basically for the written this specific heat sensible heat latent heat of evaporation or saturated temperature this sometimes some surveyors might ask as a cross question like what is saturated temperature they will ask you why a compressor is provided so आपका आंसर क्या रहेगा to increase the saturated temperature and saturated pressure now he will ask you what is saturated temperature क्या बोलोगे तो आपको पता होना चाहिए ना what is saturated temperature it is
यस
a
सर
boiling point only but in terms of water we call it boiling point but others के लिए हम boiling point नहीं बोलते हैं ठीक है is it clear
यस सर
समटाइम्स ओके आई एम नॉट सेइंग यू रट्टा नहीं मारना है सिर्फ अगर आपको इतना ये एग्जांपल्स भी याद रहते हैं ना दिस इज मच मोर देन इनफ ठीक है 1 डिग्री टेम्परेचर इंक्रीज करने को स्पेसिफिक हीट बोल रहे हैं विदाउट द चेंज इन स्टेट इफ टेम्परेचर is changing but the phase is not changing so how much heat we are supplying corresponding to that is sensible heat Okay. Now, if the temperature remains same and the phase changes, so whatever heat we are supplying for achieving this, it's known as latent heat. ठीक है? Latent heat of evaporation है same चीज but for 1 unit of mass or the liquid. ठीक है? Then saturated temperature is the boiling point itself. Okay. So this is much more clear for you. Is it clear?
Yes, sir.
Yes, sir.
All right. Now, important thing, sometimes they will ask you, tell me some of the properties for refrigerant. I'm still on the basics parts, huh? ठीक है? मेरे को समझ आ रहा है that some people might think कि बहुत, I'm going too deep right now. But I have seen these questions being asked, what is saturated temperature? I have seen the question asked, what is latent heat? Okay. And I have seen the questions in writtens about your pH and TS diagram. And this reverse Carnot cycle, I have not seen they have asked in orals or writtens till now. But this principle was recently in previous month or previous to previous month was asked on what principle refrigeration air compressor works. Okay. So that is why I'm going a slight in a deeper manner to a class 2 level. Okay, I'm explaining you the terms. Is it clear?
क्रिटिकल प्रेशर और क्रिटिकल टेम्परेचर थोड़ा समझ नहीं
आपका आवाज धीरे आ रहा है गाइस. कैन यू स्पीक
Sir,
लिटिल बिट लाउडर?
क्रिटिकल टेम्परेचर एंड प्रेशर सर थोड़ा डाउट
हाँ,
होता
तो
है
वो तो बताया ना आपको मैंने, क्रिटिकल टेम्परेचर एंड प्रेशर. दिस इज आल्सो वेरी इंपॉर्टेंट पार्ट. हाँ, वो तो आपका उसी में आ गया, राइट? दिस इज
थोड़ा
योर क्रिटिकल प्रेशर.
समझ नहीं पा रहा हूँ सर थोड़ा.
हाँ, समझ नहीं पा रहे, ठीक. ऑलराइट. नाउ फॉर एग्जांपल क्रिटिकल टेम्परेचर ले लेते, ठीक है? So critical temperature is, it is the maximum temperature at or above which a gas cannot be liquefied. Suppose karo, my critical temperature of the refrigerant, for example, it is 85 degrees Celsius. That means agar if the temperature of the refrigerant in the cycle exceeds this temperature, okay, it will never be able to liquefy. Okay? Suppose karo, after the compressor, what compressor will do? It will increase the temperature.
Yes sir.
Isn't it? For example, आपका engines ले लो, when the air is getting compressed, the temperature increases.
Yes sir.
Here in place of air, I have refrigerant. So that means the temperature increases. Suppose the temperature increase more than 85. That means I will never be able to condense it in the condenser now. Is it clear?
Yes sir. Okay.
बोलो, is it clear?
Yes sir. क्रिटिकल प्रेशर.
ओके, पहले ये चीज समझ आया, क्रिटिकल टेम्परेचर.
यस सर. द टेम्परेचर तब उसके नीचे अगर ऊपर रहेगा तो वो लिक्विफाई नहीं हो पाएगा सर ऐसे.
दैट मीन्स आई वांट अ रेफ्रिजरेंट जिसका क्रिटिकल टेम्परेचर विल बी वेरी हाई. डू यू एग्री? सो दैट आई डोंट रीच दैट स्टेट इटसेल्फ. आई विल गो मे बी 200 डिग्री सेल्सियस for critical temperature. That will be much better for me, isn't it?
यस सर.
ताकि after compression, suppose the temperature reaches 85 also, it is still much below than the critical temperature. Agreed? I don't have to cross it. That is my main perspective, right?
ओके सर.
Now critical pressure is the same thing. ठीक है? मिटा दिया मैंने. Okay, I'll write it again. It is the minimum pressure below which a gas cannot be liquefied. Okay, can somebody explain me? बोलो, कोई है जो एक्सप्लेन कर पाएगा क्रिटिकल प्रेशर को? It is the
Yes, sir.
minimum. It is the minimum pressure below which a gas cannot be liquefied. हाँ, बोलो अभी आप.
Sir, at constant temperature, the minimum pressure required to maintain
एग्जाम्पल से बोलो, ठीक है? फॉर एग्जाम्पल आप कोई भी एक प्रेशर ले लो, ठीक है? फॉर एग्जाम्पल आई गिव यू वन प्रेशर दैट इज 10 bar. Suppose the critical pressure for my refrigerant is 10 bar. Now what?
Sir, suppose for a refrigerant, the critical pressure is about 10 bar, and So we have to maintain the pressure at 10 bar at constant temperature so that it would not change the phase of
अच्छा
that
सुनो
refrigerant.
सुनो सुनो. Suppose I have chosen a refrigerant in which the critical pressure is 10 bar. Now you understand this. It is the minimum pressure below which a gas cannot be liquefied. That means my compressor should be able to generate much more pressure than 10 bar.
Yes,
अगर
sir.
वो एक अगर सपोज करो 8 बार ही जनरेट कर पा रहा है माय कंप्रेसर आफ्टर द कंप्रेशन. नाउ दिस इज माय एक्चुअल आफ्टर कंप्रेशन. ठीक है, सपोज करो 8 बार. सो इट इज द मिनिमम प्रेशर बिलो विच अ गैस कैन नॉट बी लिक्विफाइड. दैट मीन्स 10 बार से नीचे कंप्रेस कर रहा है अगर मेरा कंप्रेसर. डज इट मीन आई विल नॉट बी एबल टू लिक्विफाई इट नाउ?
Yes, sir.
एग्रीड, एवरीवन एग्रीज. आई आई वांट कि इस 10 बार से ज्यादा ही प्रेशर जनरेट करे माय कंप्रेसर. डू यू एग्री?
Yes, sir.
Yes.
Yes, sir.
Yeah.
But we have to also mention the temperature, constant temperature also.
नो नो नॉट. उसको कॉम्प्लिकेट मत करो अभी. ठीक है, समझने के लिए. ठीक है,
Sir, from
डोंट
the
कॉम्प्लिकेट.
evaporator, it's coming to the compressor, but compressor need more than 10 bar. So then we can convert from gas to liquid. So if it is more than 10 bar, we cannot convert. So that is called critical pressure.
या देखो, सपोज करो आपने एक रेफ्रिजरेंट लिया. ठीक है, रेफ्रिजरेंट. नाउ इसका क्रिटिकल टेम्परेचर इज फॉर एग्जांपल 85 डिग्री सेल्सियस एंड क्रिटिकल प्रेशर फॉर दिस पर्टिकुलर रेफ्रिजरेंट इज 10 डिग्री 10 बार. ठीक है, दिस इज योर property for the refrigerant at this moment. ठीक है, now if my compressor is unable to compress the refrigerant. ठीक है, रेफ्रिजरेंट को ही कंप्रेस कर रहा है. एग्रीड. इफ इट इज अनेबल टू कंप्रेस इट टिल 10 बार, सपोज 8 बार ही प्रेशर जनरेट कर पा रहा है, then it will never, this refrigerant will never change its state to vapors to liquid.
Liquid. Yes, sir.
It will never be able to do. Similarly, during the compression, if the temperature reaches 85 or more, again vapor to liquid, it will not change. That means I need a refrigerant whose critical pressure is low and whose critical temperature is high. Do you agree?
Yes, sir.
Yes, sir.
ठीक है, सपोज करो क्रिटिकल प्रेशर टेम्परेचर इज नाउ फॉर द रेफ्रिजरेंट जो हमने लिया न्यू वन, इट इज 200 एंड क्रिटिकल प्रेशर इज 5 बार. सो if after compression it is 85 degrees Celsius also, will my vapor will change to liquid?
No, sir.
Yes, it will change. And if my critical pressure was 5 bar and my compressor is generating 8 bar, again liquid to vapor to liquid can change. Is it clear? Critical pressure, critical temperature now.
No, sir.
Yes, sir.
नहीं आया तो बोलो. हाँ, दोबारा देखेंगे एक बार.
समझ गया.
थोड़ा आप धीरे बोल रहे हो यार, मेरे को समझ नहीं आ रहा. Is it
समझ गया
clear?
सर. Yes, sir.
Okay,
Clear, sir.
good, good, good. So this is also important. Sometimes they are asking in cross question, what is critical pressure, what is critical temperature. So ये जो first page है, the first page is very important regarding your orals. Whenever they will ask question regarding the principle of operation, this 5 points should be by heart to you. ठीक है. Later on, this reverse Carnot cycle, if you want to skip, you can skip. ठीक है. But COP is important over here. ठीक है. बट अगर टाइम मिलेगा तो पढ़ ही लेना, थोड़ा सा ज्यादा डिफिकल्ट भी नहीं है. वेपर कंप्रेशन साइकिल, दीज दे आर आस्किंग इन रिटन्स. ठीक है, ये रिटर्न से पूछते हैं. टीएस एंड पीएच डायग्राम बनाओ. एंड दी स्पेसिफिक हीट, सेंसिबल हीट, इसमें से भी सबसे ज्यादा जो इंपॉर्टेंट है दैट इज लेटेंट हीट, दैट दे विल आस्क यू इन your orals and your saturated temperature. These two things are very important because we will be using it quite often. Saturated temperature and latent heat. ठीक है, is it clear?
Yes, sir.
Okay, so this was for today. अभी टाइम नहीं है इंथैल्पी एंट्रोपी डिस्कस करने का, but still I will write some points regarding the चलो आज इतना ही रखते हैं, कल देखते हैं बाकी, ठीक है। एनी अदर क्वेश्चन गाइस? और समझ आ रहा है? द बेस इज क्लियर टू एवरीवन?
Yes, sir.
Yes, sir.
या दिस इज द बेसिक दैट यू शुड बी एबल टू अंडरस्टैंड, देन ओनली जो मैं आगे बताऊंगा आप लोगों को समझ आएगा, ठीक है। ऑल राइट, कल टुमारो वी विल बी ट्राइंग टू अंडरस्टैंड द साइकिल, आई विल शो यू द साइकिल, ठीक है। आई वांट यू टू टेक अ स्क्रीनशॉट ऑफ इट एंड एवरीवन प्लीज ड्रॉ इट, ओके, ऑन योर नोट्स, सो दैट कल टाइम वेस्ट ना हो। just- So this diagram, please take a screenshot of it, okay, and kindly draw it, okay. एक बार इसको draw कर लेना, and we'll discuss about it tomorrow. Okay, this is your cycle, complete cycle. Okay, how the things are going and all. And this shaded part, please do not draw it. Okay, this shaded part, please do not draw it. Okay. Rest all, you please draw it, name it, temperature and pressures also I have written over there. Okay, exactly you make it. Is it clear? बोलो guys, is
Yes,
it clear?
yes, sir. Yes, sir.
Yeah. इसको ड्रॉ करके रखना, ठीक है, सो दैट आपको कल टाइम ना वेस्ट हो, एंड विल डिस्कस अबाउट दिस डायग्राम टुमारो। चलो, दैट इज फॉर टुडे।
सर
हाँ,
सर इसको अपलोड करवा दिएगा तो एक बार और देख लेंगे तो थोड़ा सा और स्ट्रांग हो जाएगा ना बेस से, प्लीज अगर हो पाए तो सर आज ही।
ओके, आई विल सेंड इट, ठीक है, आई विल सेंड इट राइट अवे ओनली, डोंट वरी, बट आई डोंट नो व्हेन दे विल बी अपलोडिंग इट, ओके।